Okay, so box plots are also used for visualizing distribution, but they don't display the frequency. They summarize some important aspects of the distribution. They sort of display the frequency, but not quite. Okay, so here's what a box plot looks like. They're called box and whisker, the box being obviously the bit in the middle, this bit here, and the whisker being these bits on the end, which tell you the sort of limits. And the way to interpret this figure is as follows. The middle 50% of measures are put in the box. So that is telling you where most of the values are. Okay. The median line, so where the middle value comes, is shown there with this orange line. And the whiskers, these two bits on either side, show you the distribution beyond the box. So is there, these are like how spread out the bell shape is. If the bell shape's very spread out in a histogram, then the whiskers will be long. But there's a limit. Matplotlib will have put a limit of only 1.5 times the length of the box. So each whisker will only go up to 1.5. And then any values beyond that are called outliers. So anything that is beyond 1.5 the length of the box. So the length of the box obviously is determined by how many values, 50% of the measurements fall into. That determines the width of the box, and then that determines the width of the whiskers, and then that determines what are outliers, what are considered outliers by Matplotlib. Okay, that's what the interpretation is, but it's kind of hard to see with just a picture like this. Let's have a look at some examples. So here's the high volume, and what you'll see there is, let's look at the code first of all. So the code is, we're selecting those columns. We're just selecting the high volume columns. Do a figure, we do a box plot of those columns, but we transpose that data. And then just labeling it, that's all those lines. And that's it. That's all we need to do a box plot. Okay. Once again, it's showing that product F, this one in the middle here, has a much narrower spread than product A or even product L. And it's also showing that product A has got a lower median. So I think if you remember, F is the highest selling product because the median's higher. But there are some days, because of this whisker, you can see here it's higher than the whiskers from F. That means there are some days when A outsells F. L, on the other hand, has a much wider spread. So that's the length of the box and whiskers, and it's even got some outliers. And there's an outlier there at about 300. So it has a much noisier, much wider distribution. Okay. 5, 6, and 7 do the same for the other medium, low, and very low volume products. Okay. So all we need for those figures, all we need to do is take this code and just change this list of selected values. Okay. And there you can see box plots for all of them. And that gives you a good visual comparison of how the different products have different distributions. So you've got things like D here, where most of the values actually, there's this big box at the bottom, which actually is telling us, although it doesn't make it clear, but actually there's an awful lot of them. Well, perhaps it does, because the median line is down here at 0. It's saying that at least half of the values are 0. Okay. It's telling us that this one, T, is much noisier than any of the others in this low volume. And some of them have like this one, is that P, I think, has a very tight distribution, but a few outliers on either end. So if you see this narrow box, it means a tight distribution, but maybe some outlier. You often get outliers for those things. When you look at, when you go to the very low volume, you see a lot more outliers, and that's because it's very low volume data. There's not many sales happening for those products, so you tend to get more noisy data because one sale here or there can make all the difference in terms of producing outliers. So quite useful, these things, and they're used to try and understand the distribution. It does make sense, by the way, to show these segmented plots as the scales are so different. So rather than trying to put all these, if you try to put all these box plots on one chart, it wouldn't be very helpful, because the very low volume ones would just sort of disappear. They'd be too small. They'd be swamped by the other ones, by the high volume. So it makes sense to segment the data for this, for the purposes of this visualization. Okay, I'm going to finish that video there, and then we'll start looking at seasonal variation.